Hi, you guys. This is Mrs. Plateau. If you're watching this video, you are getting ready to do the reteaching tool for the first formative in the ecology unit. You need to have the page in front of me or in front of you right now printed, and so you can take notes along with us. You can find that in Schoology in the same folder that you found this video. So we're going to talk about energy in this unit, and for our retake, the main three things we're focusing on here is, do you understand how to make a food chain? Can you convert that food chain into an energy pyramid and use the rule of 10% to calculate the amount of energy available at each trophic level? And then can you look at food webs and make predictions about different changes or impacts on that ecosystem? So if we're talking about energy, the main objective we're looking at is, where do you get your energy from, right? You're always told in the morning when you get up, you have to eat breakfast. Eat breakfast so you've got energy for school in the morning. But where is that energy coming from, right? If you eat breakfast, maybe you had some eggs, which would have been from a chicken. How did the chicken get its energy? Okay, what did it eat? So that's what we're going to focus on first. We're going to follow the path of energy flow. And there's two different ways that people tend to draw their food chains. And there's only one correct way in biology to draw a food chain. In question number 1, take a peek at our food chain here. Notice it starts with the grass, and then it moves to the grasshopper, and then to the frog, and then to the python. But something's funky about this food chain. Those arrows are pointing in the wrong direction, okay? So what is wrong with it? The arrows go the wrong way, okay? So you'll want to write that down on your packet page too. And what those arrows are showing us is a very common mistake when students go to make a food chain, is that they think a food chain is telling us, well, okay, the python must eat the frog must eat the grasshopper, but really that's not what we're focusing on, right? My question is not who eats who. My question is, how do we get the energy we need in order to survive? Okay, so where does that energy start? Where does it come from? Well, the very first place it comes from is the sun, right? So the sunshine itself, I'll draw it over there, that's going to provide the energy that our plants need in order to grow. So plants can do this really special process called photosynthesis, and energy is going to go into those plants, and those plants are going to store that energy in a form of sugar, okay? We don't typically draw the sun at the beginning of a food chain. We really just like to start with the producers, the ones that are doing photosynthesis. So we're going to start our food chain with the grass, and I want to trace the flow of energy through that food chain. So we'll start with the grass, and I'm going to show my arrow going over in number 2. The energy passes from the grass into the grasshopper, right? Because when the grasshopper eats the grass, it's going to get the energy from that producer. And then the energy from the grasshopper then goes into the frog. And then that energy from the frog goes into the snake. So keep in mind when you're writing this down that you want to actually show me where the energy is going. Okay, where is that energy going? And that's the direction you draw your arrows. So don't make the common mistake of who's eating who. Make sure you're always showing me the energy's flowing from the bottom of the food chain, the producers, up to those top level consumers, okay? The next thing it tells us to do is we need to label these different levels in the food chain. And these are some terms that you learned earlier in this unit. You can go back to your notes over the where does the energy go activity in your packet to find the definitions of these. But I remember these by, here is the very first level. That's always going to be the producers. Okay, the first one's always the producers because they're the ones that can do that special job, right? They're the ones that can take energy from the sun and they can convert it into a usable energy for the plant. And then where does that energy go next? Well, when a grasshopper eats that plant, the grasshopper is the first one eating. So the term we're going to use for first eater is primary for first. And then the word consumer. Consumer means to eat. If you consume something, you're eating. So our primary consumer is the grasshopper. And it just gets that name because it's the first one in the row of eaters that gets to eat. So the frog one then, it's eating second, right? So it's going to get the term secondary consumer. And then finally, we get to that snake, which is our tertiary. And that might be a new word for you, but it's just like secondary and primary. Tertiary means third. So that's our third level consumer in this food chain. Okay. So you should be able to do that on a quiz or a test, be able to accurately label those in the correct order on a food chain. The next thing you're going to be asked to do on this worksheet, it says, what is the original source of energy in a food chain? Be careful here. Don't tell me that the producers are the original source, right? Where did the producers get their energy from? Go back up to my picture up here. That energy starts with the sun. Okay, so you can say sunlight, the sun, or light, something along those lines. All right, our next task, number 5, says accurately place the organisms above into the energy pyramid below. So when they're talking about the organisms above, they're looking at the food chain that we used just a second ago, the grass, the grasshopper, the frog, and the python. An energy pyramid is a representation of how much energy is available to each level of the food chain. So I'm going to start with grass at the bottom. Okay, because they're the ones that can get energy directly from the sun. They have the most energy available to them, right? And then the grasshoppers come next because they're our primary consumers. And then we get frog, and then the python. And there's no trick to this. It's not confusing at all. It's just the order of the food chain is exactly the same order you write it into the energy pyramid. So if you see the food chain up above, start with the producers at the bottom and just follow that food chain up your pyramid. It should be pretty simple to get those in the correct order. But now let's talk a little bit about why the producers are on the bottom and the python is up there at the top. Why does it have this triangle shape? Well, remember I told you the grass, or our producers, they have this ability to get energy from the sun. And that sun is like this giant bar of gold. There's so much energy in there that the grass can pull out, in this example, 150,000 kilocalories worth of energy for that population of grass. Our question is, if there's 150,000 kilocalories available to the grass, then how much energy is available to our primary consumers, which in this example are the grasshoppers. And this is where we learn that rule of 10%. The rule of 10%. Okay? And it's not a perfect rule. It's not exactly going to be 10% every time. But generally, what is understood is that however much energy is available to the producers, only 10% of that energy is actually going to be passed on to the primary consumer level. And you have to think for a minute, why is it that there's 90% of that energy lost from the grass to the grasshoppers? Well, part of it is the grass has a job to do, right? It's not doing photosynthesis so a grasshopper can come along and eat it. Okay, so a lot of that energy is used up, and it's also lost as simply heat. So when we get to the grasshoppers, 90% of that energy is lost. We only have 10% of that going into the primary consumer levels. That's why this is called the rule of 10%. Now there's a few different ways that you can think of calculating this in your head. But if you absolutely need to use a calculator, then you just take that number and you multiply it by 0.1, and that gives you 10%. So in a calculator, I can write this down. You would take 150,000 times 0.1, okay, which will give you your answer. And that's fine. If that's the way you need to do it, that'll give you your 10%. But an easier way, if you know anything about 10%, is you could just tack a 0 off at the end, because that's going to be your answer. So here's my 150,000 kilocalories, right? And I can take off one of those zeros, and my new number becomes 15,000, okay? Or another way to look at this, whatever's easier for you, maybe instead you've got 150,000, okay? What we're actually doing when we take that 0 off the end is we're moving the decimal point back one space, okay? So again, if it's just confusing you, what I showed you those other tricks, you can just do 150,000 times 0.1. If taking off a 0 each time is easiest for you, which I think is the easiest, that's what I would do. But you're not always going to have this nice perfect 0, 0, 0, 0 number, right? So if you get to the point where you've got a larger number and you don't have a calculator, you can go with this method down here where you're moving the decimal point back one space each time, okay? So then you'll have an accurate 10% calculation. So I'm going to go with the easy one because I've got all zeros here and I can do it. 150,000 calories is available to the producers. So I went from having 1, 2, 3, 4 zeros. Now I've only got 1, 2, 3 zeros. Okay. Don't forget your units. It's always important that we put units on so we know what you're talking about. Okay, so 90% of the energy got lost. Now we're going to go from the grasshoppers to the frog. Remember, it's called the rule of 10%. Nothing is changing here. The same is true. Those grasshoppers are using up that energy. That's energy is being lost as heat. So now the frog population is coming down to eat on the grasshoppers. How much energy is going to be available to that population of frogs? Okay, we can write this down. So we're going to take off 1 0, right? We had 1, 2, 3 zeros on the grasshopper level. Now we're only going to get 2 zeros. And don't forget your units. And then finally, we can do the same thing for the python. And again, I'm going to take the easy route here, take off a 0, and there is how much is available to that python. Okay. So now let's go down here and answer the question number 6. It says, if there are 150,000 kilocalories at the producer level, that's here, okay, then how many kilocalories are available at the primary consumers? This is requiring us to understand the definition of that word primary consumer, right? So the grasshoppers are the primaries. We just labeled those up top, right? The frogs are the secondary, and the python is the tertiary. So that's how that works. So I'm just going to look at the number. I wrote down to the next to the grasshoppers, which the answer is 15,000 kilocalories. All right, so let's use those numbers to help us answer question number 7. It says, why do most ecosystems usually have very few large predators? Well, look at our number of kilocalories available to each population of animals, okay? Let's say the python, remember the python only has 150 kilocalories. Well, what if a hawk were to swoop down, or a population of hawks needed to live in this environment, and they're eating on the pythons? How much energy is available to them? Well, the hawks would have about 15 kilocalories. You see our numbers getting smaller. Let's say maybe there's a larger predatory hawk out there that's even bigger than these hawks, and it's out there eating. Then we're down to 1.5 kilocalories. Look at what's happening to the amount of energy available to a population the higher and higher we go on the energy pyramid. The amount of available energy, here's your answer, the amount of available energy to consumers decreases as we go higher on the trophic levels. Okay, so the top predators have less energy. Which means they can only support a smaller population. All right, decomposers. Number 8, what do decomposers do? They're unique. Decomposers actually break down dead stuff. Okay, that's their job, so I can write that down. And I'm going back up to that energy pyramid here in just a second. So they break down dead stuff. You've probably heard of bacteria, and fungus is a good example of a decomposer. So what are these guys doing, and why are they not included on the energy pyramid? Decomposers are unique because they don't actually feed at a particular level. In fact, they're going to break down, I think I'll use red here, they're going to break down dead grass, they're going to break down grasshoppers, frogs, and pythons. And notice how messy that is? The decomposers actually feed on all levels of the energy pyramid. Okay, so there's no real pretty spot to put them on, which is why they're typically left off of the typical energy pyramid that you would see. All right. Okay, let's shift into talking about food webs. And all a food web is a bunch of food chains that have been put together. Hopefully in your card matching activity you had a chance to try this and build your own food web. But we're going to go back to that vocabulary, right? Producer, primary consumer, secondary consumer, tertiary, fourth level, and then the others vocab words down there. So if you need those definitions, again, remember they're in your packet. You can find them with that Where Does the Energy Go activity. So our producers are always at the beginning of a food web or a food chain. Be careful. Make sure you're always paying attention to the directions that the arrows are flowing. Sometimes we trick you and we turn the whole food web upside down so the producers are actually at the top and not at the bottom. That's why you have to really focus on what direction those arrows are going. In this example, the producers are at the bottom. Okay, so those are our plants. So it asks for an example of a producer. There's a plant. How did I know that was the producer? Because there's no arrow pointing to it, right? It's at the very beginning and all the arrows come off of that. So the producers are the ones that are taking in energy from the sun and changing it into sugars for our primary consumers to feed on. Remember, primary means first, consumer means to eat. So when we're looking for a primary consumer, we're looking for the very first animals that are eating. So I could write a bunch of examples here, right? The rabbit eats first, the squirrel eats first, mice, birds, herbivorous insects. All of those would work. I'm going to choose the mice. That's an easy one. Secondary consumer. So if primary consumer means first eater, then secondary consumer must be my second eater, right? So since I chose mice the first time, let's just keep going with that. So the mouse is my first eater. The grass is my producer. Okay, so my producer, my first eater, let's say the fox, is a good example of a second eater, right? Because we go first eater, second eater. So here's my fox. Guess it's plural, foxes. All right, now it's asking for a tertiary or third level consumer. Well, I've pretty much found the end of my food chain I've been working on now, so I need to pick a new food chain. But I want to find somebody that eats third. Let's see. Let's try starting with the herbivorous insects. So if I start here, my herbivorous insects are the first ones eating. I'm going to follow this arrow right here to my insectivorous birds. They're the second ones eating. And then I can follow this arrow here up to the hawks and owls, which makes them my tertiary consumer. So I'm going to write hawk for my example there. Fourth level consumer. Did you notice as I went through this 1, 2, 3 example for you for my tertiary that there were a bunch of other arrows that I could have taken? Let's try taking one of those paths and see if we can get that hawk or owl to now be a fourth level consumer. So I'm going to start over at the beginning here. I'm going to go back to my herbivorous insects. There's one. Then I'm going to go to my spiders next instead. There's 2. Then I can go to my insectivorous birds. There's 3. And then I go back up to the hawks and owls. So fourth level, I could actually write the word hawk again, right? Because that owl can feed at, or that population of owls and hawks can feed at either the fourth level or the third level, depending on which path you take through the food web. All right, an omnivore. An omnivore is something that eats 2 different levels. It means it has to eat a producer and it has to eat a consumer. So we're looking for any example of an omnivore. And now that I'm looking at this, there is no example of an omnivore on this food web, and that's okay. Let's put on the omnivore definition. It has to be something that eats producers and consumers. Okay, or you can say it eats plants and meat, and that's good for me. Okay. So if, for example, we had, and this is not a very good example actually, but let's say this seed-eating bird actually also for some reason ate mice, okay, then that bird would become a omnivore, okay, because now I can say, look, it eats the grass and it eats the mice, but don't draw fake arrows in like I just did. I just needed to show you an example. An herbivore, think of herbs like plants, right? An herbivore is going to eat plants. It's the same thing as my primary consumers. They're feeding on that producer level. So I'm going to write the word mice again. And then carnivore, hopefully that's review for you. That's any of the meat-eating guys. So a spider could be a carnivore. It doesn't eat plants, it eats consumers. A toad could be a carnivore. Pretty much, I mean, anything that's not a producer or a primary consumer is a carnivore. Okay. Number 2, it says in food web A above, give an example of an organism that can occupy more than one trophic level. That means it can eat on 2 different trophic levels. So you could have a secondary and tertiary consumer, a tertiary and a quaternary consumer. And then we'll explain why by drawing our food chains. So I showed you one example, but let's try a different one. Let's go to the snakes instead. A snake, if we look at our snakes up here, let's follow this pathway first. Here's my producer. The herbivorous insect is my primary consumer. And then I go all the way up here. That makes my snake a secondary consumer. So my food chain down here would be grass, herbivorous insects, and then snakes. Okay, so there's my 1, there's my 2. There's another pathway I can take, right? For the snakes, I could also go, that makes him the secondary consumer, but for this population of snakes, maybe instead I'm going to take this long route. 1, 2, 3, 4. That's a big one. So now I can rewrite my other food chain and start with the grass. Then I can go to the herbivorous insects. Then I can go to the predaceous insects. I'm going to do this here. Go to the toad. And then we'll go to the snake. Sorry, I had to bend that around there. But what that shows us is that it eats, there's the primary level, there's the secondary level, there's the tertiary level, there's the quaternary level. So what we're showing with our evidence here is that the snake eats at the secondary level and the quaternary, or just you can call that the fourth level, okay? So that's really the answer there. The evidence to support that claim is what I wrote and read, our two food chains. All right, number 3 on this second page. Assume an invasive species of hawk is introduced to ecosystem A. The hawk eats mainly small rodents and toads. Explain at least 3 ways the ecosystem will be impacted. All right, so we have a hawk species that eats small rodents like the rabbits, the squirrels, and the mice, and toads. Well, let's mark that. So we have a new hawk coming in that's eating these guys and this guy, right? And it's asking us, what are 3 potential impacts of the introduction of that hawk? Well, think about that hawk coming in and stealing 3 of the 4 food sources from our fox. 3 of the 5 food sources from our fox. Do you think the fox population is going to be impacted by having another species come in and feed on the food that they've been eating? Probably. So we could maybe make the prediction that the fox population loses some food and declines. Do you think maybe that rabbit, squirrel, and mouse population decline? If we have a whole new predator feeding on that level, right? That might happen. You could also argue that the hawks and the owls and the snakes might lose some food too. So you could say that the hawk, owl, and snake population declines. Okay. The main idea here is that when you're looking at this food web, that you're not just saying, oh, well, if a hawk is introduced, then whatever it eats, that population goes down. I want you to make connections farther than just the only trophic level that the hawk feeds on. You need to talk about how is that going to impact other animals that eat those food sources. Maybe instead you were thinking, wow, now there's only 2 groups that are, maybe feeding on, if this population goes down, maybe there's actually going to be more plants in the ecosystem because there's so few rabbits, squirrels, and mice left. So you're trying to make those connections on trophic levels that are higher or lower than the main one that is discussed in that example. The last thing you're going to be asked to do is to compare 2 food webs and see if you can find out which one is going to have a greater negative impact if we add that invasive species, right? So this invasive species was added to ecosystem A above, but it's also added to this one. There's my rodent, there's my frog, right? And this new species of hawk is coming in and it's eating those rodents and frogs. Well, what's going to happen to the snake population? If that hawk's coming in and eating, a lot of those main food sources for the snake, we'd probably see the snake population go down quite a bit. And if the snake population is going down because these are going down, the mouse and the frog, then the eagle population is probably going to go down quite a bit too. Okay, those are the only 2 main food sources for upper level consumers, right? So in food web B, there are only 2 main food sources for our top consumers. But let's go back up in A. Let's look at A. If you look at Food Web A, look at all of those different levels and all of those different arrows that show multiple different feeding relationships within this forest ecosystem. Okay, so the fox has 1, 2, 3, 4, 5 different things that it eats. So although, yes, that invasive hawk comes in and eats those rabbits, squirrels, and mice, probably not all of them, the foxes aren't going to be impacted to the point where they might go to extinction because they can still feed on things like insectivorous birds and seed-eating birds, right? So there still might be a fox population around. There's more available food sources for these organisms to fall back on in a food web that has more organisms in it. And we'll talk a little bit more about that in our next unit. So in Food Web B, there are only 2 main food sources for our top consumers, but in A, there are a lot of food sources available. Food Web B will be impacted more because it has fewer available food sources to survive on. All right, that is the end of the reteaching worksheet. If this seems to make sense to you, then you're probably ready to go ahead and take the quiz that's also in this folder and see how you do. You can take that multiple times until you reach 100% if you want. We'd like to see that you at least get an 80% on those retake quizzes before you come to try the actual paper quiz with your teacher. So best of luck, guys. Thank you.